I'd like thank everybody. First off, I recognize everybody has busy schedules, and we really try to curate some content for you guys to add some value. We understand your time is precious, so hopefully we can continue to prove our value by having these webinars and having good relevant content like the content today from our partner at Aimbridge Energy today. So before we get to the meat of what we're going to share today, I'm just going to run through some housekeeping and a little bit of an overview to set the context. So my name's Daniel Thompson. I'm from Schneider Electric. I'm on the North American Committee for Current OS as well as the Marketing Committee. So thus my presence here on the North American webinar series. If you have questions as we go along, feel free to post them in the chat, and then we get to the Q&A section of the webinar, I'll work through those questions as they come. We will be sending out the webinar recording after. If you have a colleague that you think is interesting, wants to share it with, or want to review it at another time, it's great to have that recording. And then finally, we encourage you to follow Current OS on LinkedIn, on YouTube. We have good content on our YouTube educational series. You spend some time checking out those videos. I think that you guys will all find them to be of value. So just talking a little bit about who Current OS is. We maybe don't have the name brand recognition of a lot of the standards bodies in North America, but we're doing our best to try to resolve that as soon as we can. But Current OS is really a few things. We advocate for direct current microgrids, and we publish a design standard reference that should promote interoperability of systems within the direct current world. So as we go through the presentation today, Aimbridge will again indicate where and how Current OS fits into the overall position. So I got to point out a small correction that 95 plus partners today. We're at 99 plus partners today. So we have hopefully a few people signing up soon, which will push us over the 100 partner mark, which is a big deal for us. Very exciting. We spent some good amount of time working up to this number, so it's great to get into triple digits. So, yeah, thank you for the plus. And we're really about projects. I mean, you go to a lot of conferences, you sit in a lot of these types of events where people talk about things, and what I really like about Current OS is we're doing things, and the partner organizations are building real projects here. And as you look at the reference sheet, we're updating and trying to include additional North American content on this slide. We have a couple new projects to insert for the next webinar, but that's what we're going to be going over today with Aimbridge and taking a look at like real projects. And you know, when Lars and Tom and I were talking about this months ago, and we were looking at, you know, what it is that would be interesting, I think one of the takeaways is that these applications aren't like crazy projects that are like wild off applications, but they're real projects, and they're approachable, they're in your community, and they're things that I think we all understand as you know, as just being members of society. So with that, I'm going to hand it over to Lars and Tom to introduce yourself and take you through the content that they have prepared today. Thank you.
Yeah, thanks, Daniel. Appreciate it. I'm Lars Bentley. I am the co-owner, and I'm mainly in business development. And then we have Tom, who's with us as well, who's our president.
Hi, I'm Tom Osterman.
Yeah,
thanks, Lars.
And then, so first of all, I want to start off say thanks to Current OS. Really appreciate you guys having us on here. It's really exciting to be working with you guys. I just wanted to put that out there. But so today, as we wanted to cover a little bit about who Aimbridge Energy is, and just a little bit about us. and then the problems facing the automotive dealership industry and how DC Microgrids can help solve those problems. Then we'll do a little deeper dive into the increasing need for EV chargers and how the regulatory environment is affecting the industry. And then also how DC microgrids can be used as branding, as well as for resiliency and efficiency. And then a quick run through just of the basics of our microgrid for those of you who don't know. And then we'll wrap up with a quick case study of one of our current projects that you can see in the photo here. So who is Ambridge Energy Group? Ambridge Energy can be thought of as a complete energy management partner with 4 primary areas of expertise. First off, we're product providers, engineers, and energy system manufacturers. We're also consultants and project managers that can provide long-term consultative partnerships and support. And then we're also systems integration professionals. This includes software, data management, BMS integrations, applications, and reporting. And we're also operational efficiency professionals and can aid our clients in branding and marketing for their business.
Hey, Lars, you talk a lot about, how the DC microgrid technologies help out the EV, the EV ecosystem right here. But, there are other values that you touched on in your intro, branding, resiliency, efficiency. I wonder if you could talk a little bit about that, because I think our audience understands, why, EV chargers, the value of bringing DC to EV chargers, but maybe if you could touch a little bit on some of those other values.
Yeah, absolutely. Thanks for that question, Daniel. So with the rapid increase in EVs that we're seeing, there'll be an obvious need for additional EV chargers. And Ambridge will have that in the forefront of our system, but we offer a lot more, as you mentioned. I'm going to go over some of the problems that auto dealerships industry is facing, and then we'll provide our solution for each problem. So first off, I'm start off with grid availability. So the grid continues to struggle to provide enough energy for its constituents. We're certainly seeing this today. Last year, the North American Electric Reliability Corporation reported that forced grid outages reached 9%, which is the highest in a decade. Then you look at longer downtimes. So downtimes have also increased as maintenance issues and technical malfunctions plague the utilities. Last year, the average downtime was 6.5 hours per customer on the commercial side, which of course can lead obviously to lost revenue. Then you look at increased demand. So over the next decade, again, per the ERNC, the demand for energy is expected to increase by 18%, which is only going to inflate the percentages of outages and downtimes. And then building loads are also increasing with addition of EV chargers, which we're going to cover a lot more in this presentation here. The loads have increased significantly for commercial buildings. And then utility companies are prioritizing some projects over others, such as data centers and critical infrastructure projects. This may cause extensive delays for projects and can be very expensive. And then pricing increases. I mean, we all know about this. The US electricity prices increased by 3.6% over the last year, which beats out the broader inflation rate of 3.2%, which is crazy to me. Then the predictions are that these prices will only continue to rise as demand for power increases, which isn't surprising. And then lastly, the new building energy codes are complex and costly. Energy codes change constantly and are both expensive and a headache to deal with. This delays projects and just adds additional costs. So let's now get into how we're going to solve these problems through our microgrid system. So we reduce the need for grid availability. With our fully managed deep energy storage, we're able to keep critical loads powered during those outages and survive downtimes. Your clients are able to keep your lights on and computers powered reducing negative revenue impacts during those downtimes through the use of our battery storage. And then for controlling demand, we reduce grid-tied energy demand by moving those off-grid to our microgrid system. Reduce building loads. We're able to manage building loads by using intelligent load throttling and smart power distribution. And we can get you to bypass utility timeline restrictions. We control access to power by leveraging renewable energy sources and DC microgrids, ensuring utility timelines don't limit project completion. And then just be able to manage your pricing. So we reduce operating expenses with peak energy price management and our intelligent controls. And then lastly, you're able to conquer new building energy codes by implementing the DC microgrid systems. You're able to give your business a head start with complying with building code regulations. So to answer your question, Daniel, we provide not only the ability for auto dealerships with our system to charge their EVs, but provide our clients with an efficient and resilient energy system and increasingly unstable energy environment. So let's getting back to the EVs I mentioned. I wanted to show you all some statistics here. Here's a report from the Experience Market Trends from Q4 of 2024. This shows the actual trends since 2021. You can see the electrical and electric hybrids made up almost 19% of new vehicle registrations in 2024. This is up from 9% in 2021, which is a pretty significant growth that will continue as we move forward. And you can see the resulting gasoline vehicle registrations are down under 65% for the first time ever. So in summary, I mean, demand for EVs is growing and will continue to grow. So with those increasing numbers, you have to ask yourself, what do modern auto dealers need to do to prepare themselves for these increasing EV sales? First off is branding, positioning, and differentiation. Dealerships need to be able to market themselves as modern and accepting of the new EV generation. EV charging infrastructure. Of course, they had to add the actual physical EV chargers to the facility. Clean energy implementation. By adding renewable energy sources, such as solar, dealerships can adapt and conform to the new energy codes. Operating cost efficiency, by just being able to hedge against the increasing utility rates and tariffs that we see going on right now. And then just being able to improve the aesthetic of the facility through the use of high density lighting. This will impact the brightness and the clean color temperature inside the facility and outside on the sales lot, which will increase sales and productivity of your sales staff there. And then resiliency, just using energy storage through a microgrid enables smart load distribution, which ensures business continuity and reliable operations. And finally, credibility. Show your walk and the talk by adopting energy efficient systems that support EVs and electrification right at the dealership.
Yeah, that's awesome. I think the credibility factor comes in a lot. I know when I bought my first EV, when I walked onto the dealership, I was almost being discouraged. You know, the salesperson didn't know what they were talking about, and they were really trying to point me towards combustion. You know, Tom, I'm thinking back to a conversation last year, RE Plus, and we were catching up. You know, I had recently taken on the new role that I have with codes and standards, and we were talking about how deep the rabbit hole goes. Can you help us walk through some of the landscape, regulatory landscape that we're looking at in this space?
Absolutely. Thank you, Daniel. And thanks again for everybody for participating today. Appreciate your time and interest. The U.S. is really trying to catch up. So we're considerably behind the international community, I think, in a lot of these areas, but trying to ramp up as quickly as possible. What's unique in the U.S. is you've got individual states that vary in terms of their public policy and adoption of energy codes and standards or lack thereof. So it's a really confusing regulatory landscape. You've got probably 5 or 6 states that are very progressive and very forward thinking and way out ahead in terms of what they require. And then you've got other states that are the opposite, that are not really prioritizing this at all. So it's inconsistent at this point. But if you look at the international standards side of it, certainly there's focus on efficient building design and clean energy implementation, beneficial electrification. There's no question that that momentum is substantial. So that certainly covers electric vehicle charging implementation standards, the lighting and use and implementation of renewable energy. Many of the energy codes are kind of a scorecard system. And so with DER, renewable energy implementation, you can get a pretty substantial amount of points that help you offset maybe disadvantages of the building design or avoid cost, such as increased insulation or glazing or what have you. So focused on implementation of renewables, and just general efficiency. So lighting is a great target, and it's an outstanding target for our world in terms of DC advocacy to focus on supporting lighting with direct DC. So you've got the international community kind of pulling ahead in the US, individual states catching up somewhat on an ad hoc basis. And in many states, you can't get a building permit for a particular project without compliance. So that will continue to evolve. Separate from all of that are the traditional standards groups, regulatory safety, and normal electrical project implementation participation we have to comply with. So certainly in the National Electric Code, we try to adhere to any other standards bodies, the NFPA from a fire protection code compliance perspective. You've got all these different agencies and AHJs that overlap in terms of their participation with permitting. So you get to this point where it's really difficult to navigate a commercial building design through all the architectural and structural design to the point of a permit approval process, and then navigate through normal safety, health, wellness, ADA compliance, and the typical building process, and then navigate through energy efficiency and energy code compliance. So that's a long way of saying that a dealership that is upgrading or refreshing their approach for focusing on EV sales and improving that clean energy adherence, they face a lot of headwinds in terms of getting a permit to construct or upgrade an existing facility. And that's where we've kind of focused our efforts at Aimbridge on the energy side of that.
I think that's really important too, Tom, right? Like, because a lot of times what you're talking about, a DC microgrid, you may be going into an authority having jurisdictions area, and they may have never seen a DC microgrid before, right? So it's very important that we can point back to not only the current OS design reference standards, but also, you know, all of the other agencies that are out there. I wanted to ask, and you know, I don't know, maybe Lars, you can field this, right? Like, so you talked about in your earlier comments, you know, about sales positioning. You know, can you explain a little bit about, you know, what that value is? I think that again, the audience understands efficiency, they understand resiliency, but you know, what explicitly are you talking about when we talk about sales positioning?
Yeah, so I love this slide. I think we can all recognize the image there on the left, kind of the crazy tactics dealerships have traditionally used to get the public's attention. So replace the gorilla, I mean, the 800-pound gorilla there, or whatever old school marketing approach that the dealers are using and have been using with the image on the right. I mean, it's night and day. Be able to promote an earth conscious, modern image for dealerships. I mean, if you read this quote, in the hyper competitive landscape of auto dealerships, differentiation has transitioned from a competitive advantage to a survival necessity. I mean, that's pretty powerful, survival necessity. So to answer your question, Daniel, by adding a kinetic solar sculpture, awnings, and canopies, dealerships can differentiate themselves from the competition alongside just the mere addition of the EV chargers.
Yeah, that's awesome. I love that how it grabs you from the front, looking at the dealership. It really puts up not only a solution but a good looking solution. Can you talk a little bit more about the other componentry throughout your solutions?
I'll jump in on that one. So as Lars mentioned, in the auto dealership vertical or use case application, it's all about branding, differentiation, kind of competitive sales focus, and bringing folks into the lot. So that's the front end kind of marketing and branding part of this. But electrically, this stuff has to work. And so the electrical component implementation, I'm sure the engineers in the audience are kind of interested in that. Our focus is really to tightly integrate the solution in a scalable cabinet-oriented configuration, as opposed to the traditional kind of ad hoc approach with multiple components that are conduit interconnected. So we wanted to make this drop-in, very unitized, scalable, and able to be leveraged in this environment from an installation or time to connectivity perspective. So we've got high efficiency, embedded energy storage with the ability to add additional cabinetry for energy storage. We're really focused behind the meter. We do have the ability to have a grid tie interactive capability, but we'd really rather steer our clients away from that and really focus on taking load off the utility, self-generating, self-storing, and distributing that for direct DC loads to really concur with the approach that current OS is taking. We really think is the right approach. So our product configuration is tightly integrated and easy to drop in and install. And we're trying to stay away from interaction with the utility company from a permissibility perspective, or grid-tied inverters or power production agreements. We want to direct feed client load off the system. We'll go through a couple of slides here on just power flow. I think all of you are familiar with kind of the schematic representation of a microgrid and all its components. But in this case, we've got energy generation, primarily solar, embedded battery storage, smart DC distribution, and ideally, we'd like to aim our clients at as many loads as they can convert over to direct DC loads. We see all those icons in the lower right in the slide. We still preserve the ability to feed legacy AC loads with full-time inversion, but we try to deprioritize that if at all possible. In a car dealership opportunity, what do you have for loads that are a great load profile target? That's lighting, and lots of it, very high density, high intensity lighting, both inside and outside. So that's important. And then they're facing this increasing load for EV charging. And so how do we support that net new load? So the power flow diagrams show you in this configuration, we can run off of internal storage. We can run off of solar during the day that's supporting the load. And then we have utility rectification so that we can lean on the utility if we need to. So if there's a problem with the generation, or our storage resource is not sufficient, we have utility as the backup. So as behind the meter, we're trying to self-generate, self-store, self-distribute, and then the utility is our backup if we need it, or for maintenance or downtime issues. Another interesting use case, of course, is peak shaving, and this is really focused on for rooftop traditional grid-tied solar, particularly with adding storage. And it's quite interesting with certain states have significant tariffs for penalties for high peak charges. And if you can clip the peak off of just a brief period of time during the day, it's the equivalent in terms of cost reduction of supporting the load for the majority of the day. So with this case being behind the meter, we're trying to avoid even having peak exposure. It's a little different spin on this than the AC inverter peak shaving approach. So I'll hand this off to Lars. We have a really interesting kind of specific case study. Back to Daniel's comment, this is a great project discussion. Take it away, Lars.
Yeah, thanks, Tom. Yeah, I just wanted to give you a quick run through of one of our projects we're currently working on here. It's an auto dealership in Denver, Colorado, where I'm based out of here. And I wanted to mention some of the issues the client was facing and was looking to address. So first off is there's a dated facade on the building, poor aesthetics, and it's just an old building. And then there's extremely poor lighting, both inside the building and outside on the lot. Rapidly increasing utility costs, which is affecting everyone, but I think in the auto industry, yeah, it's really getting up there. And then the lack of brand recognition among other dealers in the market, as we mentioned, it's a really big deal, just to be able to stand out. And then concerns with utility grid outages and weather events, be able to stay, have business continuity on that side. And then finally, the need for EV charging infrastructure, which really every auto dealer is looking into now. So you saw this image at the beginning of the presentation, but I want to go through it a little bit more detail. As you can see front and center there, there's a kinetic solar sculpture that will actually follow the sun during the day to maximize the amount of sun it's getting. And then it'll fold up at night, or if there's high winds during the day, which is pretty cool. Then behind that, attached to the building, is a solar awning. If you go back one here, Daniel.
Yeah, there you go.
Solar awning, and to the far right are some solar canopies that include EV chargers to charge inventory. They're also practical, protecting inventory from hail, which is a big thing here in Colorado, and also other events, weather events.
Yeah, you probably get some good shading off that awning too, that reduces your HVAC load, I would imagine, right?
That's true. Yeah.
Oh yeah. So yeah, that whole office, there's offices there in that building, and it gets up to 100 degrees. It's unbearable. So it was actually the client that actually brought that to us and wanted that to help that. And also the canopies cover the cars. So if you're in Arizona, you're not walking around checking out cars in 110 degrees. You got some coverage there as well. So that helps out for sales side of things. Yeah, here's a photo of the roof. There's a 36 kilowatt solar array mounted on a ballast racking system, which means there's no roof penetrations or no structural modifications required. This keeps the building envelope intact. This actually has been installed and has been in use as a primary energy source for the DC microgrid. All right, for the final phase of the renovations, we're deploying a dedicated outdoor system to power all dealership lot lighting and security cameras using direct current. So each pole includes 4 high-efficiency LED fixtures and a network-connected PTZ camera, all routed through the same PoE network, which all of these are very important for these auto dealers. One, for the lighting for sales in the winter, be able to get out there, it's dark, be able to sell those cars, but also for security, for having those cameras and that lighting. They have 5 to 6 cars stolen every year. Just to help out for that security would be tremendous for them. And here's the service area. We replaced the old high pressure sodium lamps with 250-watt LED high bay fixtures that are feeding directly from our microgrid with DC energy. The difference in the lighting was amazing when they installed it, and we received a lot of compliments from the service staff who were using headlamps before for full time because the lighting was that bad. Yeah, to conclude, we're able to improve the lighting both inside the building and outside the lot. We're able to control utility costs through our energy management system. The kinetic solar sculpture, solar awnings, and canopies created a unique branding recognition. And then we're able to provide security and resiliency for the dealership by being able to power specific loads during grid outages and weather events. And finally, offer level 2 EV charging configuration that is directly DC fed.
Awesome. Let's see. So, one of the things that I caught you saying a few times, the implementation, faster connectivity, and provide resiliency as well as the EV charging and this clean energy positioning here. Can you talk briefly about how how that happens? I mean, it looks like you got a lot going on in the system here. So
Yeah.
how are you able to drive down that implementation time?
Let me take those all individually. So for the faster connectivity, our fully integrated DC microgrid streamlines the connection of solar and battery storage to EV chargers, reducing that complexity, accelerating the time to operation. Then you look at the resiliency side. Our on-site batteries paired with the intelligent load management ensure that the critical systems like the lighting, security, and EV charging that we mentioned remain online at all times, even during the grid outages and weather events. And then you mentioned the clean energy positioning. So highly visible solar and EV infrastructure demonstrates that the dealership's commitment to sustainability, reinforcing the brand leadership and alignment with the OEM electrification goals. Tom, did you have anything else you want to add to that?
Yeah, I think that's a really effective overview of the feature set, and the time to connectivity issue that we're finding in a lot of markets is really the utility company is in the way, ironically. It depends on the structure of the utility company, if it's an investor-owned utility or a municipal PUD or a rural co-op. They have different levels of kind of perceived cooperation with renewable energy. But before you can even get in front of an AHJ or municipality for a permit application for a project that involves traditional solar, rooftop solar, grid interactive, you have to get the utility company's permission first. And that can add a year or more to the permit timeline. So they're basically slowing down implementation of renewables if it's connected to the grid just due to their own processing delays and workload and backlog. So we want to stay away from the utility, be behind the meter, and not be grid interactive. So that's one point to eliminate that 6 to 12-month delay of utility permission in advance of permit application. The other is just the integrated solution being more drop-in and not customized per site, I guess, or ad hoc. It's kind of a plug and play drop-in. And then I think the other thing we think in terms of speeding up project deployment that's still admittedly being evaluated and kind of tested in the market is the EV charging deployment. I visited 20 to 30 dealerships. Our team has looked at a lot of dealership locations in multiple states. And if you look at the way EV charging has been implemented, it's very inconsistent. Maybe just a few level 2 chargers. They're not the same brand. Some of them don't work. It's not very impressive in a lot of cases. So we're thinking that part of the story here for fast deployment of EV charging is to make it unitized, plug and play, interconnected, all the same charger configuration, and just more of them. Having them in the service bay, the showroom, the lot for clients, for charging of vehicles after test drives, and just make it ubiquitous and kind of a common configuration. So we'll see how that goes. It's early, but we think that resonates with our dealership clients.
Awesome. Thank you, guys. I kind of understand what you're saying. We go to a lot of conferences, we're in a lot of sessions. People talk about the next new like shiny thing on the horizon, which might be grid interactivity or demand response or V2X type programs. But I think that's probably something that gets left off the slide is that adds time in the utility interconnect queue as they try to figure out what you're doing. And sort of if I could distill the takeaway here is that you're telling your clients to basically to take care of themselves first and handle their own destiny, and then later if someone wants to be grid interactive or expand the system, potentially you could, but why wait to try to have this elaborate system when you can deploy a system that accomplishes your goals without the time associated in the development cycle.
Yeah, that's a good point. And I wanted to address resiliency. We just kind of briefly touched on that. So in this market niche, do we need long-term battery backup as a standby kind of business continuity application? Probably not, with the exception of the external lot lighting, because those lights run in the evening during there's active sales activity to some point, but then they stay on the rest of the night from a security perspective.
Hmm.
But from a resiliency and business continuity perspective, this particular market niche probably not so much in terms of being high on the priority list. We've done some other work in residential housing developments where we've pursued this resiliency hub idea. And in that application or niche, you flip the script 100%, where it's all about resiliency, safety, backup, and kind of a safe space for people to go if there's a weather event or power outage. The same hardware, the same system could address those opportunities that are more focused on backup, business continuity, resiliency. Not so much a priority here. So our goal is to have a toolkit. So depending on the client or the market vertical, we can address any of those and adjust the priorities accordingly.
And I love that thought, Tom, and thanks for taking us there. I think in my own head, as I looked at your slides, as we're walking through the presentation today, I think that, yeah, we're talking about your specific, target area of dealer franchises, but I think in today's world, we're seeing these same common elements. There are, cameras everywhere. There efficient lighting. I know that it was a bit of a something I hadn't thought about before, but when my wife started driving my EV and she had the occasional need to charge when she was, a distance from home, she made the comment to me like, well, why are EV chargers always put in these dimly lit side alleys or behind a building or whatnot?
That's
So,
right. Yeah.
being able to provide that level of lighting and security, I think is a goal for the entire industry.
Excellent point. And you're right. I've been to a lot of charging locations where you're kind of pulling in and wondering, do I even want to risk being here from a safety and security perspective?
Yeah.
And really, those charging locations should be brightly lit, compelling, safe, welcoming spaces. And that brings up another topic, which is kind of amenity charging, I guess, is a term that's out there. So having EV charging be ubiquitous in various retail environments so that you can top off, and it's not a deep charge, it's not a supercharger or fast charge need, it's just a convenience. So retail establishments offering charging just for their clients to have it be a convenient reason to come to that location. There are some dealerships that we've interacted with where they put in EV charging as a destination charge location where clients or not even clients, but people that are on road trips can pull in and charge at a dealership. And the funny story is that while they're waiting for their car to top off being charged at that location, they're walking around the lot and doing what? Looking at vehicles. And this one dealership said he sold, this is a Ford dealership, I think 5 F-150 Lightning trucks and then some Mach-E's. So here's an EV client already that owns an EV coming in to charge at a dealership as a destination charge location that ends up buying a cool new EV. So the whole EV charging approach across all market verticals, I think, is really interesting. And we really think that front-ending those with DC, with a microgrid approach, just makes so much sense. It really aligns with, I think, what our goals are, certainly at Current OS.
Awesome. Yeah, I couldn't agree more. So as we're coming to the end of the slide deck here, we're going to open up the Q&A shortly. For any Current OS partners on the line, just wanted to put a plug in for the Cleveland, Ohio General Assembly. This is the first plenary that is occurring outside of Europe, so it's very exciting to see this in North America. If you're not a partner, there's still time to join up. If you would like to come, we can help expedite that. Just reach out. And now we're on to Q&A time. So not a lot of questions in the chat today. So, that is the lovely situation where I get to ask more questions. And we'll see if, if people, stop being shy or have other questions. But, our last topic, we're talking the early days of EV charging. I heard the acronym the 4F, right? Factory, fleet, freeway, and franchise. And freeway is a kind of a cute term for in transit charging, right? And so, when I look back at the presentation, how different would a solution like this be for, say, other types of applications, like maybe a workplace charging application? I mean, is that something that you guys have paid much thought to?
I'll take that one. Yes, we have. And what's, I guess, unique about our approach, and I think it's early in that we're testing the market and we're testing various client relationships and project opportunities. So we're on the bleeding edge of this and learning. But our infrastructure is a low voltage DC distribution, at least from the front end of the level 2 charger that we've developed. And so, of course, a level 2 charger is an AC output. So that, in our case, includes the DC distribution, the value of a DC microgrid, and everything DC to the point where we do have to up convert, to AC to feed the charger gateway. So the question is, do we have to have full level 2, 19 kW output capability, or can we do level 2 slow charging or dynamically allow chargers to share the limited DER resource? And so that remains to be seen for municipal fleets or for what I mentioned earlier, amenity charging. Do you really need all of those level 2 chargers to be fully enabled and fully capable for maximum output? Or is it just slower rate of charge for an hour or two, or for the workday where someone's parked and in the office, and that's a slower charge rate? And is that acceptable if there's a lot of charging connection points? So the whole premise of that is, what if you had 20 or 30 chargers on the lot, all low cost, all sharing the same behind the meter resource support in terms of total kW, but then allow that distribution across all those chargers to vary in terms of some prioritization? Who needs more charge, who doesn't? So we're testing that, Daniel, in different markets to see, could that work? And does that make sense? Is it cost effective? It's early.
Yeah, it's awesome to hear that you're exploring that, Tom. So thanks for that. Keep us up to date on how that works out. We have a question in the chat. It's saying, any definition of peak shaving timing or duration using alternative energy that can help driving the design and selection for a megawatt range system? Like, but maybe before we get into that, like what we walk through today, like what is your typical sizing of a system like
Yeah,
like you
good
showed?
question. Yeah, we didn't address that. So our cabinet configuration is a 25 kW building block, and they can be paralleled. And so we're aiming at, typically less than 150 to 200 kW is our sweet spot. And we think it's really more likely 50 to 75 kW, just focusing on the lighting load part of it. So we're certainly not at half megawatt or megawatt level implementations. Now, if you add the EV charging part of it, well, that'll scale up very quickly, particularly if you have full even level 2 compliance, let alone level 3. So in the dealership context, lighting is number one. Lot lighting and internal lighting, PoE, all those other IT loads that are great at 48 volts DC are not a high density load. We can easily support those. So we're not at that level of kW capability. South of 200 kW is kind of our target. But back to my earlier comment, for other market niches where you have a lot of charging locations, a lot of individual charger pedestals in a lot, what should that be? Is that really a 500 kW or megawatt level, or do we throttle that back? And where should we be in terms of total kW? Don't quite have that answer yet.
Yeah, I've been exposed to a little bit along on that topic, and really it's when you've seen one microgrid, you've seen one microgrid, and
I
like
love that.
doing the load analysis. I was just looking at yesterday. A colleague sent me a community microgrid project to review, and looking at like how they're sizing on that, and just thinking about how different this is. But I would imagine, the approach is the same. And if you're going to start adding in DC fast chargers, or something that you're getting to a megawatt scale, the building load becomes less significant, and now you're just scaling your storage and your production to sort of support whatever your ambition is with DC fast charger. Is there something else that I'm missing there, Tom or Lars? Like, how would you approach?
That's a good point. So I think what we're trying to do is help with the initial implementation of charging, to take a dealership from where they are today, which is de minimis, maybe one or two chargers on the wall, and maybe they don't work, when you really look at what exists, and at least stand up some better infrastructure, better than what they have now, to improve the branding and differentiation and the focus of the dealership, so that it looks like it's aimed at clean energy and EV charging, right? It's never going to be a DC fast charger, really high load environment at a dealership. However, many of them have put in a level 3, charger, maybe one, and they kind of feature it prominently and have signage, and they light it and they put it in front of the showroom. It's really more for branding than it is for deep use. So I don't know. I think at that point it goes back to a traditional AC front-ended. If you have that kind of density of intensive charging, fast chargers at a dealership lot, then that's just not going to be supported from a low-level DC microgrid approach, or that's not our focus point. I think we want to pick up that first pass of improving dealerships with a relatively light load, and more visible charger implementation at a level 2 or less.
Mm-hmm. Vinay is asking a question online here about the HVAC load, and let's see, these for much higher electrical loads and lighting, and I believe OEMs are already working to develop solution. Can you talk a little bit about, are you replacing with heat pump, or are you just feeding the existing load? Like, how do you approach that?
Yeah, that's a great question. There are mini split configurations now that'll run on 48 volt DC. Typically, it's like a 1-ton capability. It's not overwhelming in terms of its capacity, but it is moving that direction of a direct DC version for an HVAC configuration. If you look at the dealership environment, these are soaring, high ceiling, big showrooms that have a lot of cubic space. And back to that whole state energy code compliance issue, really difficult, because now you're trying to have that sales impressive space, soaring ceiling area with a lot of airflow needed. So the HVAC density for these dealerships is a huge footprint. It would be really difficult, I think, to stand that up with a full renewable system that would pick up the majority of that load. We see other markets and other niches where that would be more viable, direct DC and even low voltage DC microgrid support of smaller heat pump mini split loads to some point. And that's in the less than 50 kW range.
Yeah, I think too, we've had recently, I think in the last 6 months, we've had Train and Daikin join Current OS. And
Yeah.
I know last year Train was present at the RE Plus at the Grid Edge Theater, right?
That's
And
right. Yeah.
John from Train was talking about how, they basically bypass the front end and come in with DC direct to the heat pump. And that wasn't necessarily a current offer of theirs, but it seems to be that like that may be coming sooner than we expect. And I don't mean to speak for Train or any other current OS partner. It's just that I believe we're getting a little bit closer for having DC HVAC systems out of the box.
Oh, you're right. And I've had those same discussions, I think, even with Train and participation in the past with eMerge. And you're absolutely correct. You can bypass that front end rectification stage and go right in and eliminate that conversion loss, which is all about efficiency, which is great. And if it's not an AC induction motor anymore, but a digital kind of scroll compressor or stepper motor equivalent, that whole infrastructure is DC past the rectifier anyway. So why not go directly in, or have a dual input scheme where you can feed it with AC or high voltage DC and just bypass the input rectification side. So I don't think it's really hard. It's more of a market chicken and the egg problem, right? Do they bring the product out and try to push it, or wait for the market to adopt it, or a little bit of both? But I don't think it's a technical challenge. And that goes for other AC loads and appliances, refrigerators, in the residential space. What about, appliances being fed by high voltage DC that just bypasses that input rectification stage? And so I think that will come. I don't think it's a technical problem. It's a marketing, sales, and kind of market adoption challenge.
Yeah, and it may be the difference between greenfield and brownfield.
Mhm.
You're targeting existing franchise operators here that depending on if it's an older system, it may warrant replacing with new HVAC, or if it's a newer building, then maybe the system's fairly efficient, and they don't see a return on the investment there. So I think that aligns with Vinay's comment in chat. Thank you, Vinay, for the question. Dave's also asking, are you providing or seeing integration of fault managed power, class 4 power, DC distribution in DC microgrids yet? And I don't know, Tom, Lars, if one of you want to take that question. Are you seeing FMP yet? I know we hear a lot about FMP, but
That's a great question. And I have to admit that we have picked a strategy to stay low voltage DC wherever it makes sense. And there's certainly constraints there in terms of transmission or conductor losses, right? At low DC voltage and high current at a class 2 level. In my years of data center and telecom experience, that was a big talking point in terms of fault managed power and high voltage touch safe implementation, because of the significant energy density where you're approaching 100 kW per equipment rack, and you want to distribute at a high voltage. How do you do that safely and effectively and with management? So for now, we're watching that. We don't have a dog in that fight yet in terms of our product implementation, trying to stay at a low voltage, fairly low kW level. But it's interesting to watch. I'm curious, anybody else in the audience that has waded into that or has some viewpoint on that.
Yeah, we can check that in a second, Tom. I just want to make sure we get to every question that's in here as we're approaching the top of the hour. Andreas is asking, in simple terms, what would be the key indicator to assume a DC electrical infrastructure would be more efficient for a factory or commercial building? Is it on the load or the source side? Should there be a minimum threshold of energy consumption, or is it always associated with building new infrastructure?
Oh, there's a lot to unpack there. I can say that we looked at a use case. Picture a concrete tilt-up warehouse configuration, just logistics space, a fulfillment warehouse or business park with warehouses. So what do you have in that environment? You've got huge rooftop space, so plenty of room for PV. Inside of that warehouse, you have high bay lighting, which traditionally was high pressure sodium, mercury vapor, very inefficient. And so if that entire space was LED lighting, now you've reduced significantly the heat load of that building because you're not dissipating that waste heat of those former light fixtures that were inefficient. Mm-hmm. So you've made a dent in your HVAC load reduction goal. You have much quieter, high density, clean lighting, far more efficient. And then you stop, because what else is in there? There's forklifts, maybe a few folks, pallet racking. And so that's an interesting one where you can make a really easy argument for a DC microgrid for that being super efficient, super cost effective, and you could completely stay behind the meter on that front, assuming you have the storage capability. And do those warehouses run at night, or are they dark so that the load goes to a minimal level? For other CNI applications, I'm sure it's all over the map in terms of what would make sense from an efficiency accomplishment. Back to energy codes, there's a lot of locations where you don't have a choice to even make that value judgment. They're going to tell you, you have to score at this level in terms of your energy efficiency to even get an approval for a building permit. So now you're faced with what's the best bang for the buck in terms of where do you spend your dollars to accomplish energy code compliance? And is that solar? Is that insulation? Is that a more efficient heat pump? Or what's the combination of investments that get you over the top to accomplish a building permit?
Oh, that's an excellent point. The mix of where you choose to invest. I mean, sometimes you're making a sacrifice just to get something, in line with an owner's budget. So
Right.
I appreciate, I've been in that situation many times before. I appreciate that comment. Graham makes a comment on the chat about displaced ventilation systems could be a good approach to dealerships, but he also recognizes that it is very difficult to retrofit an existing building. So again, green versus brownfield coming into play. And then Pierre had a comment on one of the earlier comments in regards to DC fast charging in the megawatt scale. Unless some other DC chargers can come into play, 7 kilowatt DC chargers to replace AC chargers, and I think we've seen that in our past webinar with Intelligent, where they have a DC input
That's right.
charging that's like a 20 kW. It's an L2 plus rating
Yeah.
size, but I think if you're looking at something other than in transit charging, a nice L2 plus charger, that's going to scratch the itch of most EV drivers. I feel like my wife and I make more and more decisions about where we're going to shop and eat at based upon where charging's located. And I know that would move the needle for me, but yes, ultra fast charging is nice if you're, on the road and, trying to make several hundred mile distance trip
Oh,
in
yeah.
a same time.
That's a good point. Well, we're testing that idea. What if you had a level two that was only at 3 to 5 kW? Would that even be acceptable to anybody? And I think if you're just trying to do a top off or you're parked there for the workday and you only burned, 10 miles of range to get to work, maybe that's acceptable. In some cases, I think it would be. Or for amenity charging, where it isn't that road trip, quick stop, fast charge, and then on the way you go. So I think there's a slice of the market that's low kW, but high volume of charger locations and just as a convenience.
Oh
Why
yeah.
couldn't a lot have 20 or 30 chargers and you just plug in, and if you get 10 miles or 20 miles or 1 mile, you're still parking there. Why aren't you plugged in?
Yeah. Yeah, and have a variable pricing model associated with it, so people
Exactly.
maybe have choice.
Right.
We're coming up on our time here at the top of the hour, though, so I don't want to um, run out of time before thanking both Tom and Lars for joining us today and walking us through their approach to DC Microgrid. As always, thank you to Prashant and Rafael for helping produce this webinar series. Very much appreciate your support. And again, if any of you on the audience today have any other questions or comments, we're a community here. You can reach out to Tom or Lars or myself on LinkedIn, and whatever we can do to try to get an answer for whatever's burning question you guys have, we're more than happy to do so. So thank you again, everybody, for joining, and we'll see you next time.
Thanks for having
Thanks for
us.
having us.
Appreciate your time.
Thank you.